Hi everyone, this is my 212 graphics programming game demo. So as you load up the project, this is what you're greeted with, which is the main menu. Once you press G, you load up the game itself. The first object that probably stands out is the spaceship, which is a metal cube. I could have made this slightly more advanced and complex, but I wanted to save on vertex attributes in the vertex shader. So, kind of moving on, to move the spaceship, you use the up and down arrow keys, and then you can look left and right, and then rotate by using those keys as well. So moving on with camera angles, this is the main camera angle that you're given, kind of just behind the player. However, if you press H, you also get a bird's eye view camera angle, and you can interactively change these throughout the game. So if you want to switch to this one, you just press G, H, G, H, and you can change those whenever you want. The next noticeable thing is the skybox. So you've got the front side here, the left, right, top. Now I'll just show you the back side. There you go. And then if you press F, there's just a camera showing you the bottom side of the skybox as well. So I'll quickly go into detail and explain to you how I made the skybox. So as you can see from the diagram on your screen now, you can see this is kind of the basic structure of a skybox. So the 1, 2, 3, and 4 sides are basically the general sides of the actual skybox, whilst 5 and 6 are the tops and bottoms of it. So what you do is you divide an image into kind of 6 sections, even sections, and then you apply those individual images to each individual face, and then it creates a seamless effect. Okay, moving on, so another thing that I included was mip mapping. So if you look at the racetrack, which I'll go over in a second, the ground and the skybox, there's mip mapping applied to these 3 objects. So if I move a little bit further back, you can see everything past my mouse cursor here is it's a lower resolution texture, whereas everything closer is higher resolution. And same with the racetrack, if I move closer, and same with the skybox as well, everything goes to a higher quality. So what I'll do, I'll explain how mip mapping works to you. So on your screens now you can see a basic kind of representation of how mip mapping works. So the 8x4 grid is the base texture in its full resolution, and then if you were to move slightly further away, you'd then be displayed the 4x2 resolution, which, as you can see, what it's done is it's taken the values, averaged them out, and then basically what it's done is it's compressed them. So the resolution's lower and it's less accurate, but it's easier to compute. And then if you were even further away, you'd be given the 2x1 grid and then the 1x1 grid, just to kind of show the different stages of how mip mapping operates. Okay, so as briefly mentioned as well, the racetrack is a torus. I decided to do that over an object loader just because this gives the racetrack shape, and it's much simpler to implement. So I just put a texture over it, works how I wanted it to. So here you've got asteroids that are dotted across the map, and also the sun. The sun's just there for visual purposes, but the asteroids you can collide with, and they bounce you back, so they're kind of like obstacles throughout the game. Okay, so as you can see on the torus as well, there's lighting. So the light object is up here, and this is obviously a shadow because it's out of the light, and then here it's fully lit up because of it being in the light, and I'll explain to you what lighting model I used for that now. So on your screens now is the diagram used for the lighting model that I used, which was Fong's lighting model. There's 3 stages to it. You've got the ambient lighting, which is kind of the most basic stage, and that's kind of just like your background lighting, kind of the very basic stuff. And then what kind of adds a lot to the image and the object is the diffuse lighting, and what that does is that's mixed with the ambient lighting. And that creates a lot more depth, some shadows, as you can see, and just makes the object look a lot more realistic. And then finally you've got the specular lighting, which combines the 2 previous stages, but then also adds some light reflections on the top of it, which makes the object look a lot shinier, and which again looks realistic. It adds sort of how the light interacts with the object. So on your screen now you can also see the 2 diagrams that I used. On the left you've got just how the ambient and diffuse lighting's calculated, and on the right you've got the ambient and diffuse lighting, but then you've also got how the specular lighting works as well. I think despite having some issues with the vertex shader and not being able to load all the vertex attributes and making my spaceship a lot less detailed, I think overall I've met kind of the main requirements, especially with the lighting and texturing, as well as kind of adding sort of extra objects into the game. The only thing that I'd probably add is particle systems and an object loader, just to make sure that the game looks a lot more refined and kind of interesting and engaging to the players.